This video is for my pre-calculus students. We're going to be doing lesson 44 today. I'm going to be focusing on pages 223 and 224, and let's get right into it. It's called the graphs of polynomial functions and factors of polynomial functions. A lot of what we're going to be doing here today is stuff we've talked about in class, but they're going to throw in some new information that's important. This very first example at the bottom of page 223, 44.1 says if f of x equals this, at what values of x will the graph touch the x-axis, and at what values of x will the graph cross the x-axis? You notice they didn't ask us to graph it. They just want some basic information of where it's going to cross and where it might just touch. If we multiplied this whole thing out, our first term would be x to the 12th, and we know that that's a thing that has a dozen loops in it, or actually 11 places where it turns, but it'll be going up at both ends because it's x to the 12th, and 12 being an even number. So as we go through here, I see that we have x plus 4, so that means at negative 4 here, I have a 0. Meaning it's going to cross the x-axis there. I have this x plus 2. That means I have a negative at negative, yeah, I'm saying this wrong. At negative 2, I have a 0 also. We're going to not fool with this x squared plus 3 yet. We'll come back to that in a minute. I have a 0 at x equals 5. 1, 2, 3, 4, 5. And I have one at positive 7 also, because of x minus 7 squared coming. Now, what they're focusing on this lesson is these powers that are important here that we're dealing with. We know that if I have x minus 7 squared right there, that'll be a parabola. That's a change in x. And it's a parabola that's going to come down here, and at 7, it's going to cross like that. Okay? Or go like that. It does not cross the x-axis. It only touches the x-axis. If I have an even power, my quantity is to an even power, this 2, this 4, or a 6, an 8, a 10, that tells me my graph is only touching the x-axis. It is not crossing the x-axis. If I have the quantity to an odd power, a 1 or a 3 or a 5, that means it crosses there. So here at negative 4, because it's x plus 4 to the 1 power, it's actually going to cross the x-axis. Here at the plus 2, x plus 2, that means at negative 2, it's simply going to touch the x-axis like this or like this. The book doesn't ask for specifics. Is my graph going up like this or down like this at that point? It's just touching. Because we haven't multiplied this thing out and we haven't taken everything into consideration and tried to graph it, I don't know what's happening down here. There could be lots of up and down movement or stuff. Probably it's going to be like this one here, going down, but that's not, they're not even asking that right now, so I'm not even going to say which it is. I'm not sure. Here at x minus 5, because it is to an odd power, that means my graph is going to be going like this or like this. It is crossing at that point. And again, I don't know if it's going up to the right or up to the left or down to the right, whatever. That is not relevant, but it crosses here. It crosses over here. It touches here at negative 2. And because this minus 7, x minus 7 is to a positive power, also there it's touching also. And it may go like that or it may go like that. That's all they're asking in this. Now we need to consider this x squared plus 3. In the discussion, in the text above this example, they tell you that this x squared plus 3 can never equal 0. because I can't say x squared equals negative 3. In fact, if I were to graph just x squared plus 3, it'd be a parabola like that never touches the x-axis. This right here does not cause your graph to touch the x-axis at all. And in this consideration, where in this question where they're saying, hey, does it touch or not, we can pretty much just ignore that whole quantity. It's kind of irrelevant to the question. Okay? So that's all they're asking you in the first one. Does it cross or does it touch? We go to the second one. And it says y equals x minus 1 quantity squared times x plus 2 quantity squared. And they ask us to determine what your graph is going to look like. And they give you 4 examples there, 4 possibilities. If I were to multiply this out, I can tell you my very first term would be x to the 4th. So I know my graph is probably going to look something like that. Okay? It could look, like this or other things, but basic shape, it'll look like that. So the first 2 in consideration, we can just toss them out, okay? Not even considered there. If you were to multiply this out, your final term would be negative 1 times negative 1 times 2 times 2. Negative 1 times negative 1 is positive 1 times 2 is 2 times another 2 is 4. I can tell you that this is going to cross the y-axis at positive 4. I can also tell you that because it's x minus 1 quantity squared, it is just going to touch there. It is not going, well, I marked the wrong one. Excuse me. It's going to cross, it's going to just touch right there. It's not going to cross the x-axis. And it is just going to touch right there because changes in x. So my graph is probably going to look something like this. And if you look in the book, this is the one they give you in letter C. They've got this loop here peaking on the other side. It's irrelevant. It actually could have turned around there at that 4. We don't know. But we know that it just touches here at negative 2, touches at positive 1, y-intercept at positive 4. So letter C is our only option, okay? And did I mess up? No, letter D is our option. Oh, they did do it the way I did it. I was looking at it wrong. I thought in letter D they were having it cross the y-axis at positive 5. So we got D. Let's move on. In 44B, graphs of polynomial functions, this is stuff that we've talked about in class before. Depending on the power of your polynomial, if it's x to the 5th, you're going to have 4 loops. If it's an x to the 1 looks like this, x squared like this, x cubed, and we've talked about this before. If you have an odd power, your graph must cross the x-axis at some point. If you have an even power, nothing says it has to ever cross the x-axis. It can, but it doesn't have to. If you go to the bottom of page 225, they give this this equation y equals ax to the 4 plus bx cubed plus cx squared plus dx plus e. And here's 5, 6 possibilities of what your graph could look like. Now, the first one where it's just a parabola, the only way x to the 4th would look like this is if it was just simply y equals x to the 4th, maybe plus some constant, plus 5, plus 7, minus 2, whatever. It's going to look like this. If you start putting any x cubed values or x squared or x to the 1 values in there, it starts to affect your graph and make it go up and down. So there's all the possibilities for y equals x to the 4th. If you turn the page to page 226, they show the possibilities of if you put a negative in front of it. Y equals x to the fourth versus y equals negative x to the fourth. And it's just all those possibilities on the previous page flipped over. Right above example 44.3, they give some detailed instruction. In fact, it even says an in-depth study of polynomial functions will reveal several interesting but seldom discussed properties of polynomials. If you wish to read that, you may. But like it says, it's seldom discussed. It's one of those things that only shows up a couple times in this book. I don't spend my time on it. If you wish to read that and get that extra information, you're more than welcome to. It's going to show up in one of our examples here in a moment, but it's not going to be irrelevant, but it's going to be, we didn't need to have it. Well, the 44.3 says make a very rough sketch of the graph of y equals negative x cubed all the way down to plus 3. I'm going to leave out all that stuff that's in the middle, but because it's x cubed, it'll look like that. Because it's negative x cubed, my graph is going to look like this. I know that it crosses the y-axis at 3, right there. And they show this, and they show it going like this, or they show it and having an inflection in it like that. The only way your graph y equals x cubed is going to look like this is if it simply said y equals x cubed. If you add all this other stuff in the middle, which they do, and I don't know what that other term is, minus 2x, that's going to cause your graph to go up and down a lot more. So this is what your graph is going to look like. Now they talk about this finding the inflection point, the part that I skipped right above this example. And they show, oh, this could be point, 1,3. But then you would have to come over here. We know that our y-intercept is at 3. And in that graph that they show there on the right-hand side at the bottom of the page, they're showing the y-intercept higher than 3. Because we knew the y-intercept was 3, I guess they could have done something like this. But the way they have that one drawn, we know that it's not it. At top of page 227, it says make a rough sketch of y equals x to the fourth, and all this down the line plus 5. Again, because it's x to the fourth, I know it's going to look basically like this. It has to cross the y-axis at positive 5. It cannot be the first one there. They show just a basic parabola. Because it's y equals x to the fourth minus 3x cubed plus 2x, that's going to make all those loops and curves in there. So this one here is really not relevant. All the others are. We don't know which one it is. They aren't asking that. Okay. In my next video, I'm actually going to go over lesson 44 and a lot of the questions that I assigned, and we're going to do it together just like I would in class sometimes. See you guys soon.